My name is Scott Vanderveen. I'm the owner of Pro Composites, and I sell plans for the Vision aircraft, which is a cross between a Lancer and a Glasair. And it's first flew back in '97 or so, and there's about 400 set of plans are out there, and a few of them have been flying throughout the years, but it's a scratch-build aircraft. So if you got lots of time and you want to learn composites from the top to the bottom and bottom to the top, that might be something to consider. I also teach sporter workshops around the country, and I enjoy doing that. We'll do about 15 of them a year, and check the schedule if you want to learn more about composites. Today's class is on working with carbon fiber. We do a little subset of that in the sporter workshops. It's a 2-day intensive. So today we're going to talk about a few tips and tricks about working with carbon fiber. This is more or less for a home builder. We're not going to be using prepregs or discussing the ins and outs of using that with refrigerated items and things like that. This is basically something that hopefully you can apply if you want to use carbon fiber in your own types of designs and such at a more of a economical level. Okay, so moving forward here, why carbon fiber? Well, it's typically twice as stiff as steel by weight, 5 times stronger by weight, excellent strength to weight ratios, and that low coefficient of thermal expansion makes it really a go-to choice for materials. You know, obviously if an aircraft's sitting on the ramp at 140 degrees Fahrenheit or so, and it goes up to 30,000 feet, obviously it's going to change it. It's going to want to change its shape. At least normal materials will do that. Things get hotter, they get larger. Things get colder, they get smaller. Carbon fiber has a property where it actually gets slightly smaller when it gets hotter and slightly larger when it gets colder. So infinitesimally small that by adding a resin system to it, it equals it out. So it actually has a virtually zero coefficient of thermal expansion. How does that compare to other materials such as fiberglass and aluminum? Well, fiberglass is somewhere around CTE of about 36, aluminum somewhere around 24. So very much a big difference in coefficient of thermal expansion. Lastly, it's one of those things that just caught the public's attention, and everybody loves the way it looks. You know, we love that cool carbon fiber look, and we like to incorporate it into instrument panels, and if we can, maybe build things that are structural out of it. Let's talk about a few challenges of working with carbon fiber. First off, the cost of materials and tools. So that has been easing a bit over time. Back about 20 years or so when I started to get into composites, a yard of carbon fiber, standard cloth, was about $50 a yard. Nowadays it's about $20 a yard. The reason for that is because of all the efforts on making cars much lighter. It's called lightweighting is their term for it. They're trying to replace standard materials with carbon fiber, and with that lots of aircraft are now being made out of carbon fiber. So the world manufacturing or the capacity or supply of carbon fiber has gone up, and with that, us home builders, we can actually get it for a lot cheaper than it used to be. Also, the tools required, it's not as easy to cut or trim and sand as standard composite materials such as fiberglass, so that may be something you may need to invest into as some better tools. Next is UV degradation. Just like any composite material, you set it in the sun, it's going to degrade over time if the surface is not protected from UV. Next is galvanic corrosion. This acts kind of like a metal, so if we fasten it to things, it could just standard hardware, and you get a little moisture in there, it can start to dissimilar metals have a tendency to corrode, and in this case it will do that also. Next is these carbon fibers relatively brittle compared to other materials such as fiberglass, so that's something to consider when we're working with carbon fiber. And sometimes it's kind of, I'd call it's too strong. Say you have a model or an aircraft that's been designed to use standard fiberglass, and you want to convert it to be lighter and stronger. It's kind of hard to find materials that match the original strength of how it was built originally. So it's hard to find the exact match. So sometimes it's actually too strong for the design you're considering. It may be too brittle. You need to get a little more volume back there. Okay. Sometimes it's a little too strong for what you're looking for. Next, radio waves don't penetrate through it. So also, if you bought a kit And say a Lancer per se, it's all this, you spent lots of money for this, this carbon fiber airframe, and you see these patches of what look like fiberglass. The reason for that may be in there is so you can still install the antennas on the inside of the airframe, because radio waves do not penetrate through carbon fiber. Next is, I would say the learning curve is kind of expensive. At $20 now per yard, if you mess things up, you're wasting lots of money. So, and next is the learning curve is fairly steep. It's hard enough learning composites, and working with carbon fiber can be even an extension of that and fairly difficult. I like to break down this talk into two different areas. One is cosmetic or non-structural parts and structural parts. What do I mean by that is things that are cosmetic or non-structural, things like instrument panels, where we really just want that look of carbon fiber possibly, or some type of interior panel, armrests and things like that. You really want to have this look, but it's not necessarily a structural part like a wing spar per se. And simple fairings, you want to get that lightweight by using carbon fiber, but it's really not something your life's dependent upon if it failed. Well, with cosmetic parts, our main priority behind that is reducing the cost. Sometimes we do that by just putting a facing of carbon fiber over a fiberglass part. That's one way to do it. And use a few multiple layers of material of, say, fiberglass as a backing. And if you really have to have that look, what do? You want that really glossy fiberglass look to it, then it needs to be lightly sanded and put a type of UV clear coat. Automotive paint suppliers have that now. It's a polyurethane 2-part. It's UV protective, and you can spray that over top of carbon fiber parts, and you can get this nice glossy mirror, finish on there, and it will be protected against sunlight. That's especially important if you have an instrument panel made of these materials. You let it sit in the sun, go to an event like this, and over time it's going to degrade and maybe possibly even delaminate if it is exposed to sunlight. As far as structural parts are concerned, there's serious advantages and weight savings by using carbon fiber. Things that use carbon fiber, for that are control surfaces, wing skins, and the airframe, the aircraft spar, such as those. And with carbon fiber, just like most composite materials, you can have it's easily tailored for the strength that's required. Now let's talk a bit about structural parts here. What we really want to do is increase the fiber to resin ratio if you're working with carbon fiber. What do I mean by that? Unlike normally when we're working with fiberglass and we're starting up with wet layup, which is something we probably start with. A composite structure is defined by how much resin to fiber there is in combined together. Fibers carry the load, resin holds the fibers together, and if you just have excess resin, it just means you have heavy parts. So in order to get the excess resin out, we have to use techniques such as vacuum bagging, which compacts the fibers and removes the excess resin. We're going to do a demonstration of that today. So if you're considering using any type of carbon fiber for a structural part, you really have to consider investing in vacuum bagging equipment, whether that's just with standard wet layup and vacuum bagging, or possibly if you get into vacuum infusion, you're still going to need a vacuum pump and most of the materials you use in vacuum bagging. So it has to be a controlled process. Obviously, we don't just whip things together. In fact, you can, but you're going to get different results. If you take the Composites 101, over at the Composites workshop, you'll realize, composites is a process in which I just lost the word. You just took the class today. It's a process-dependent material. So if you screw up the process, you get different results every single time. So you really have to control your process. Today I want to focus on wet layup and vacuum bagging, which is something that most home builders can do and get very lightweight, adequate results for structural parts. I'm also going to demonstrate poor man's Prepreg. What I mean by that is we're going to lay up this carbon fiber within plastic, pre-pregnate it, and then use this pregnated carbon fiber to make a part. We're not going to discuss standard prepreg and autoclave, which is another whole process which takes a fair amount of money. Pultrusions are out there. I've used them in the past. It's pultruded carbon fiber. You basically buy it already impregnated and solid, and you embed that into, say, a wing spar. Resin transfer method, RTM Vardum, which is a kind of an alternate method of vacuum bagging and an extension of that, and also filament winding, which is another whole other process that I don't think a home builder at this stage would be able to accomplish. Although someone who's a high-techy guy who knows all types of, works with Arduinos and all that, and CNC equipment could actually probably make their own filament winding machine. It would be kind of interesting to see that in the future. As far as the epoxy resin system to consider, is first off, you want to have something with minimum shrinkage. So what does that mean? You have to use an epoxy. You're not going to use any type of polyester resin for this, where you have lots of VOCs and lots of shrinkage involved. Additionally, by heating these parts afterwards, you're going to raise the glass transition temperature. That's a T sub G, it's noted that way. And some resin systems are noted for having a low T sub G, such as West System. It's roughly about 140 degrees Fahrenheit versus something like Epoxy, which we'll be using today, which is closer to 200 degrees Fahrenheit. And that can be elevated, which means it can actually get stronger, have a better working life if you post-cure it, and that could actually go to 220 to 240 degrees. And additionally, if you want to set parts out in the sun and be able to use them, and you UV protect them, but what about the heat that the sun creates? You know, it could easily get to be 180 degrees with a nice warm temperature and a nice, lots of sunlight. You can also consider using a high temp resin. PTM&W, makers of Epoxy, has a 2500 series resin, which is somewhere around 350 degrees service temperature. So that's something that's available to home builders now, and you guys can actually go ahead and acquire it and build parts that you can use inside a cowling or things that will sit out into the sun. On to reinforcements. You're going to hear things like, well, what's 3K, 6K, 12K, 50K, whatever. What does that mean? Well, if you look at the fibers, the bundles, when it's woven, it refers to how many filaments are together before they weave them together. So 3,000 filaments worth, this is 6,000, 12,000. So it means heavier cloth versus lighter cloth. And within that bundles of filaments, they will be woven in different ways, such as plain weave, twill, which we'll be using today, unidirectional, and then spread toe, which I don't have an example today, but there's a really neat looking fabric out there called spread toe, which is basically the filaments laid out flat, and you can make really stiff and solid parts with that material. And then sometimes plus or minus 45 stitch, which I have an example here, where it's actually unidirectional cloth that's been laid on top of each other and stitched together. And this may be useful for building, laying up wing skin, so you have a nice good torsional load for a wing skin. Even on top of that, there's, I'd say, boutique types of filaments or weavings out there. I don't know if you can pick this up, put it on the screen, but see it later. But there's a really interesting pattern here. You get different types of patterns done up in carbon fiber. And if you've got something that you want to highlight in carbon fiber and you like that style, you can consider that. As far as fillers are concerned, sometimes we want to have the filler that we're dealing with, instead of being white like typical micro balloons that we're dealing with standard composites, we want to have it darkened up, and actually you can use a pigment in that. We make black pigment for micro balloons, and so when you're fairing in different areas and you want it to look a bit darker, you can use black pigment to do that. As far as safety is concerned, use standard safety measures. Remember, this is just like working with other composites. The only additional thing to consider is the dust that's created is a little more hazardous, I would say, with carbon, and you want to protect your lungs, especially when you're sanding and cutting and trimming and things like that. So what did I miss here on carbon fiber? A couple things to think about. I'd like to reinforce is that in a composite structure, we really have to compact and get excess resin out if we're building structural parts. In fact, even non-structural parts would benefit from vacuum bagging, which means they'll compact the layers and get excess resin out, because after all, we really want to make lightweight parts with carbon fiber. As As far as safety concerned, I put a little thing here, dust mask, gloves are typical, a little hand lotion here to keep the pores filled. If you got dry skin, keep the dust and things like out of there. And I'm going to work through a demonstration here using Poor Man's Prepreg, a wet layup, and vacuum bagging. You can see it. Usually I learn by seeing people do things, so that's why I'm going to do a demonstration. I'm sure some questions will come up. Hold those towards the end, and we'll cover most of those as they come along. So once again, Poor Man's Prepreg. We'll do a wet layup, and then we'll vacuum bagging. So starting off, I don't even have my scissors here. For $3 at Harbor Freight, I know most of us frugal home builders shop there on occasion. They have a set of scissors that are about 14 inches long. They cost about $3. They cut through lightweight carbon fiber pretty well. So you can start off by buying a pair of scissors there instead of the $30 to $50 shears that you maybe think you have to buy. Start off there, you just save some money today. Consider buying some fabric shears from Harbor Freight. I wish I had Harbor Freight, wish I had stock in that company. We'll get into cutting and trimming in just a moment, but let me get started with this wet layup here. So what I'm going to have set up here is I'm going to change over that's sad, can't do both at the same time. So let's go ahead and flip this over so you can see the camera, and I'll kind of walk us through our layup today. That's a good start. Okay, so what I have set up for this morning is, first off, I'm going to do the Prepreg, which I have, back this up a bit. Okay, 2 sheets of plastic. This is 6 mil standard painter's plastic. You can pick it up at the home center. I have 2 sheets, and the other thing you want to consider when you're buying this is get it without wrinkles. Okay, so if you have to buy a roll of it, a good supplier is, the company that makes boxes called Uline. They sell it online, on rolls. About 6 mil plastic works great for this. And then I've got my fiberglass, rather my carbon fiber, cut to size. You can see a couple sheets up here. I'll be doing 2 layers today. Move this off to the side. And we'll be wetting this out between plastic in just a moment, and we'll pre-pregnate it. And the reason why we want to use this method is because typically when we start off with fiberglass, we'll mix up our resin, we'll pour it into the fiberglass, and it goes from that nice white color to a very clear or translucent appearance. And you can easily tell whether there's air bubbles trapped or there's dry areas. Working with carbon fiber, if you add a resin to it, it basically stays as black as it started. You really have a hard time determining whether or not it is saturated or not. So by wetting it out between plastic, what you're going to see is the plastic will become nice and wet. I mean, that's a good telltale sign that the carbon fiber is fully wetted out. Another concept to think about is consider using a touch more resin than you normally do with fiberglass, just to make sure that it's fully wetted out. So that's just another tip there. We have our mold right here, which is going to be a NACA scoop. I don't know if you can see this, like so. We're going to lay this up. This is an old mold I had sitting around, and we're going to prep that really quick with some wax. And you want to wax these molds fairly thoroughly. If it's a new mold, obviously you're going to do it about 5 times. There are products out there, they're chemically based silicones that embed themselves into the surface. One of them is called ChemLease. I've used that quite a bit, and it's much easier. Instead of having to wax and wax and wax on, wax off, you get the idea. You apply it once and you get multiple pulls out of it, instead of having to use mold release wax. In this case, we're using Meguiar's. You can actually see this. Meguiar's old release wax. Okay, sufficiently waxed for today because this has been used a few times. I'm going to set this off to the side. And actually, a couple things to think about is I'm going to make a quick pattern. I'm going to show you a couple of things here. If I put this over top here and kind of draw it like so, I've got a silver Sharpie marker. Another tip here is to, when you're working with carbon fiber, instead of using your black Sharpies, pick up a silver Sharpie, and you can easily identify, say that 5 times fast. You can easily mark black items and see them fairly easily. So I'm just going to make a quick pattern here, at least to the perimeter, what I'm looking for. And when I put my carbon fiber between there, this out of the way. It shows up pretty nicely. You can actually see it here. I can go ahead and complete my pattern. Okay, so silver Sharpies work great with dark items such as carbon fiber. Now I'm going to take this top sheet and pull this away. The other thing I want to think about is how much epoxy to weigh it. Let him go by. How much epoxy to mix up. I can do this by measuring it, and I know this is 5.8 ounces per square yard. I can figure out how many square feet I have, and for every square foot I typically put in about the same amount of epoxy to start, and because we're working with carbon fiber, we add a little bit more. That went by pretty quick. Once again, fiber to, I'm doing this by weight. If you're really into composites, you know it's actually by volume. This is a slightly different, what I'm talking about, slightly different volume. So but it's close. So if you weigh it, it works out pretty well. So I've got my scale turned on here. I can get this to here. You can see that. I can roll this up. Zero up my scale and determine that this is about 1.65 ounces. So really I need about that much, 1.7 ounces of epoxy. I'll probably increase that to 2 ounces. Would be more than enough to wet out this entire layup here, all this carbon fiber. So once again, I'm gonna stick this over here. Make sure that it fits my pattern again. Sometimes it changes its shape slightly. Okay. And once again, 2 ounces of epoxy. I'm gonna, because this is air epoxy, it's mixed 100 parts to 27 parts hardener. I'll just take my 2, which is what I want to end up with, divide it by 1.27. And it says I need about 1.6 ounces of resin. I'm gonna put some gloves on. And with new cans, and because this is doesn't use a pump system, you really need to use for structural epoxies like this. You really want to use a digital scale. You don't want to use a volume type pump for it. So what I'll do is I'll just put some into this cup, the resin, grab the hardener, and for today, this is one of their newer hardeners for this resin system. It's the 3663, and this is a 90-minute pot life, so I've got plenty of time to lay this up and not worry about it cooking off in the cup or starting to solidify. And the reason I like this also is if you decide to get into vacuum infusion, this is a very thin epoxy. When you mix it up with the resin, very thin hardener, you have an adequate working time, because if all of a sudden you're doing all this stuff and it starts cooking off in the cup, it takes a while to put these bags together, and if it starts heating up, you're basically working against the clock. So it's really important to use a resin or a hardener with a resin system that gives you adequate working time. Okay, once again, we needed 2 ounces, or rather 1.6 of the resin. I will tear out my scale here. Got the resin, so we'll put 1.6 in there. And sometimes if you just go over, what I might do is just, this says 1.7, okay, so we just start 1.7 and multiply it by 1.27 equals, now we're gonna have 2.15, close enough. Now we have a good ratio here, 2.16. All right, and those will go back in the cup later on. And we'll mix this together, usually a couple minutes or so. Want to thoroughly mix your epoxy always. In this case, it's a good, 2 ounces or so. 2 minutes would be good. All right, so if I'm working in my shop, I would be mixing this for a good 3 minutes or so, 2 to 3. Today, we'll save a minute, okay? All right, so this is all mixed together. I'm gonna go, what I could do is go ahead, take one layer down, wet it out, put the other layer over top of that, and additionally, if I was gonna have 4 or 5 layers possibly, I would probably wet out 2 first, then add a little epoxy, put the other layer over top of that, keep on going, and you get the idea, 1 at a time after that. Starting off, because it's only 2 layers thick, I know that this wets out fine 2 layers at a time. So I'm just gonna pour it all on here. And we'll move this off to the side, grab the squeegee, and starting off, I just like to lightly glide the epoxy where it needs to go. It pretty much will saturate all by itself. Okay, so it absorbed pretty quickly. I can't really tell exactly what's wet or not, but I have a pretty good idea based on how much I put in here. So I'm going to go ahead and set the squeegee off to the side here, grab my pattern. Drop that off in the center. Now comes the neat part. No more sticky stuff. So now go ahead and just squeegee from the center all the way out. And now I can see any dry spots or any bubbles very easily. If you can see that here, I might actually zoom in a bit. There we are. Let it focus. There's a bubble right here. Just work that out. Work out to the perimeter. And if you have excess resin in this stage, just push it all the way out to the edges, like so. Push it out to the sides. Back up again. Sorry. Okay. What's great about working with Prepreg, a poor man's at least, is it may look just fine up top. I don't see any bubbles or dry spots. But now we can just go ahead and flip it over and just ensure that it looks good. I see a spot right here that looks dry. You can maybe get that with the camera here. Little dry spot here, but now I can just go ahead and move some epoxy around. If I see any bubbles or dry spots, having it within plastic makes it so much easier to work with. You can ensure that it's completely wetted out. I'm going to flip that back over again. Okay, so I've got my pattern. This time I'm just using standard Fiskars or so, and because it's in between plastic, it works pretty darn well just by cutting the glass. There we are. Following that line, that works really well. Say again? Oh yeah, easier to cut now. Yeah, you'd never cut through with those scissors after it's hardened. Then I can just go ahead and throw this away. He's gonna bring me a little garbage can. Thanks, Bill. Okay. Because I'm using that 90-minute hardener, I've got all kinds of time. I would normally have my mold already set up with some vacuum bagging materials, but now that this is sweated out, I'm gonna go ahead and set that aside and go ahead and put my vacuum bag together, starting with my mold. And this is gonna be kind of a neat part, so I'm gonna get these gloves off. This is vacuum bag and release tape. We did a demo on Monday covering all these materials. Sorry if you missed it. Supporter workshops, we actually do vacuum bagging, so if you want to consider taking one of those sometime, we'll cover it in the class pretty thoroughly. You want to flip that on and flip the valve over. Widen that up a bit. There we are. So once again, this is vacuum bagging sealant tape. I prefer this because when it's cold, nothing really sticks to it very well. When it's hot, it gets super sticky, unlike, say, duct tape, where you know what happens when it gets about 120 degrees. It gets nice and gooey and slimy, and it's hard to clean up. When I'm debagging, pulling things out of the bag as it's cool, all the materials kind of pop off it, so it makes it really easy to work with. Additionally, I like using a seam roller. This is if you're into, if you've done any type of roofing before, same type of item, 12 bucks or so online, but it's nice to be able to roll this around. You'll hear bubbles pop and whatnot. Instead of using your thumb and wearing that out, it's just an easier way to put this vacuum bagging sealant tape down. All right, the next step is let's get a couple other materials set up. We have our fibers ready to go that will go over top. Over top of this today, instead of using peel ply, if we use peel ply, it's going to give a nice surface that's has a surface that's ready for secondary bonding, but for this part we're making today, we're not going to do any bonding on the backside. So instead of using peel ply, I'm just going to go ahead and use perforated release sheets. What this will allow us to make sure that our bleeder breather won't stick to the part, and it will allow these materials to fall right away when they're done. So perforated release sheet comes from your standard composite suppliers like Aircraft Spruce and Specialty, to name one of them that's very supportive of Sport Air Workshops. Okay, so getting this down here, what I might do is put a couple cuts along the edges so it fits better. What we want to avoid is some bridging, which is where the material falls away because the materials that are on top of it don't allow it to collapse nicely. All right, so that will go over top. I'm going to trim that up around the edges a little bit. So once again, this is a perforated release sheet. It allows epoxy to flow through, and it allows you to remove your bagging materials very quickly when it's done. So that's cut. Next I'm going to have some bleeder breather. I've got two thicknesses here. One is the really heavy duty stuff. So if you're laying up wing spars, you've got 20 layers of material that have lots of excess resin that's going to come up. You may want to use a couple layers of this. It'll soak up all the excess resin. If you're using lightweight parts, You know, this would work fine. It's a very lightweight material. This is it's basically polyester batting. And we'll just cut a couple pieces that will go over top. That'll fit fine. And the other thing to think about is where your vacuum port is going to go. You want to have a couple extra layers of this material so that acts as a trap for the excess resin that gets pulled up. So I always like to have a little bit extra where the port's going to go. Now that that's cut, then the last thing we'll have is we're going to use high elongation bagging film. This is the green stuff. It's called Stretchlon. It's very stretchy, and it's up to 600% its size without breaking. So it's great for this type of work. And all we need to do is have something that's about a little larger than the part we're making. Okay, so that's set, and then we have I put a gauge with a little T right here for my port where I have the vacuum pump that's going to be attached to it. I like to have a gauge so I can actually see how much vacuum is put in here. This one's been beat up and dropped a few times, so it already measures about 4 inches of vacuum. So it's a little bit off, but we could at least get an idea of what's going on there. So I'll drop this inside there, split it in half. These are very convenient to use. So now all my materials are together. I'm going to put those gloves back on for a moment. And I'll flip our pump on. And this pump has an evacuation cylinder attached to it. So it will suck down pretty quickly. Okay, this part's pretty clean, but I just don't like getting epoxy on my hands. You can appreciate that, I suppose. All right, so now that this part's been waxed, it's been prepped, I got my carbon fiber with inside my pattern. All I need to do now is just pull off one side. Toss that away. Drop this down, sticky side down, centered up. Notice the nice pattern is being still intact here. Now it's not going to bend very well with the plastic still on, so that's the last step, is pull the plastic back off. Get this out of the way. And then because this is a twill and it's cut on the bias, it's going to conform fairly well to this complex shape. Now I suppose I could just let this cure as is overnight and it would be nice and solid, but I wouldn't have very good compaction of the fibers. There may be some bubbles I don't see inside the part, and that may be a consideration. So vacuum bagging really eliminates all of that, those or at least reduces those risks. So let's go ahead and put this bag together. We have the perforated release going over top. And once again, I'm not too concerned about the the surface texture of this part on the inside, or an area that's not going to be bonded to anything else, or actually or that nobody is actually ever going to see. Now if I see a few areas if I see okay. I see a few areas that are not, because of the way it's cutting and falling away, that are exposed, that exposes the carbon fiber. Just take a few pieces of the excess material and place over top of that. You want to make sure that none of your bleeder breather touches the carbon fiber, because it's just going to stick there and not look too pretty afterwards. So my concern here is now the way this is wrapping down here, so I might put a couple cuts into here in this direction. And if you're at home, you may want to spend a little extra time than I'm doing right now, and it will conform fairly nicely along here. Here's one, two. Eventually, with enough cuts in here, it actually sucked on pretty nice. Well, with vacuum bagging, it makes things much easier because we don't have to worry about as much bubbles and things. Now that that's on there, the bleeder breather. I'm going to flip this back around again. The bleeder breather's over top. I've got some excess material where the port is going to go. We split the ports in half. One goes inside the bag. Now we're going to seal the bag up. One side down, give it a little tug to the other side. Once again, this is the high elongation bagging film. It sort of makes you look like a pro every time you use it because it stretches and you don't have to make all those little pleats around the edges. So it's much easier to use. There are instances when you may want to use the non-flexing style, but for most applications, this works pretty well. Okay, the other thing is you may be concerned about those little wrinkles around the bag. With the high elongation bagging film, you can actually just pull apart the wrinkles and it sticks right down to the tape, so it's much easier to use that way. Next, what we have, back to the seam roller, we're going to work our way around here. You may hear little bubbles pop, and so as we go around there, it's a really nice way to seal up a bag onto a flat plate like we're doing today. And over those top of those seams, really give a lot of force to this. Maybe just put all your weight into it, I suppose. Okay, now we just cut a little hole, little gap in the where the port is. Have my razor blade around here. Okay. Clean off the flange here. Get nice and clean. Give it a little twist. I think this will be fine, just like so. All right, once we put this on here, take a good look. Get the camera here. And okay. now, we'll go ahead and round the corners here, listening for any leaks. What we're looking for is about at least 20 inches of vacuum. And now you can see excess resin being pulled out into these little dots here. You can see excess resin being pulled up into the bleeder breather. And this we would let sit overnight in typically 80 degrees Fahrenheit above for adequate cure. And when it's done, we'll have a part. So if you want to come by tomorrow, we'll take a look at the part. No, actually I brought one along that we did for the next part of the demonstration. So if you can imagine, we waited 24 hours. We are now pulling our bag apart. We pull the excess resin off of the bleeder breather. We take out, this stuff got ruined when I pulled it off ahead of time, but this will just pull right away the perforated release sheet. And now we have a part which has a nice smooth interior surface. It's super lightweight, but now there's a couple other things I want to talk about. It's like, what do we do next? How do we trim this stuff? One consideration would be to wear a dust mask, but I've got a couple tools that I like to use trimming carbon fiber. One is, we all know what these, we call them multi-vibrating tools are, right? You know, everybody's seen them nowadays. Harbor Freight's got them for, you know, on sale, 14, 20 bucks, something like that. Consider buying the one, if you haven't got one yet, that has a variable speed to it, because it doesn't have to run full blast and it's fairly noisy, and that's what you're going to experience today. But what I also like is the types of blades that are available and the shortcomings in that category. If you use the blade that it comes with, it's typically a mild steel. It will dull with carbon fiber within within seconds, basically. They also have blades that are fairly thick. They're diamond blades. Those are a little bit overkill for carbon fiber or lightweight composites that we're dealing with today. So what I found at the store is something called a 4-inch diameter blade that they use for cutting tile or something like that. But it's a very thin kerf blade. I'm going to put it up here in the camera. If you can come into focus here. But you can get that from Harbor Freight, but it's a very thin kerf. I mean, it's, I think, 70 thousandths thick or something like that. And it does a really nice cut. So I'm just going to go ahead and, once the parts are cured, you can establish a trim line, I suppose, with that Sharpie marker, like so. It shows up really nicely depending on where you want to cut, especially with carbon fiber, silver Sharpie. Now I'll just do a sample cut right here. Now the goal with one of these is that you have to keep it from moving, so if it oscillates with the same speed as the part you're holding onto, it's not going to cut. In fact, these are nice and safe. They don't cut anything that's soft or vibrates with at the same speed as the head there, so it's very safe to use, but it does cut right through carbon fiber. Works pretty good, you kind of get the idea. So now we cut off the flange and I have my part. Uh-oh, power off. No. There you go, we don't want it to turn off. Okay, so I have my part, I trimmed it. This is a great tool to use for lightweight composite parts, and it works great for carbon fiber. Let me see if I can flip back over to my slides here for a few other questions. Maybe a few tips I missed. Okay, so a few things to think about. If you have lightweight composites to cut, that multi-tool with a diamond blade like we demonstrated works really well. If you've got some heavy-duty parts, like I've got something up here that's at least 4 layers thick, this may be a challenge to cut through. I might pick up a side angle grinder with a grit blade and cut right through that, or even a table saw with a carbide blade. Works pretty well on heavy-duty composites, at least carbon fiber. We learned about working using a Sharpie marker. Silver Sharpie works great on carbon fiber. The multi-tool with a diamond blade. For galvanic corrosion, think about getting, you guessed it, titanium fasteners for your home builds. All right, a little bit expensive there. If you can't afford titanium at $6 a screw, then maybe consider using stainless steel. And if you're also considered about galvanic corrosion, think about using a lightweight veil over top of it made of fiberglass, which may act as a barrier. This time I'm going to open it up for questions for just a few minutes, and then we'll go from there. Right here?
Have you tried a Harbor Freight vacuum pump?
Good question. Okay, the question is, have I tried the Harbor Freight vacuum pump? I have, and on Monday we covered the different types of vacuum pumps that are out there. I don't recommend using one of those because it typically, a pump like this has to run continuously. An oil-based pump, like piston pump like that, will pull a phenomenal vacuum, 29 inches. However, it has a tendency to overheat and produce vapor, oil vapor in your composite shop, and oil and composites usually don't mix. So it will work, but I don't recommend it just for that reason. Right there, here in the green shirt.
I know for cutting PVC, you run the saw blade backwards. Do you do that in this case as well, or do you run it forwards?
That's a good question. I think I just run it whichever way it's going. In this case, this is a vibrating saw, and obviously it worked one way or the other, and it worked just fine. So whatever works for you. I don't have any...
like a table saw.
Like a table saw. No, I found that I've worked it when it cuts towards it and gets the debris out of the way, and that usually seems to work pretty.
What's the difference between peel ply and the perforated fabric you used right here?
Okay, question was, what's the difference between peel ply and the perforated release sheet? Well, this will provide first off, it's designed to allow nothing to stick to it. So if you're building a huge layup of vacuum bagged parts, realize that this bleeder breather that's on top of it will get fully saturated. Figure you got 20 layers of material, lots of resin going in here, and when you're done and trying to pull these materials that are saturated with resin apart, if all you had was peel ply, it's very difficult to pull apart because it's almost like an additional part up there. You'll spend all day chipping away trying to pull it apart. You may ruin your part that's in there in the mold. With perforated release sheet, nothing sticks to it. These materials will just kind of fall away, and it saves you a ton of time, and it may protect your part. Now, what is peel ply used for? Peel ply will give you that nice sheen to it. As it pulls away, it gives a micro shearing effect to it, and it's basically ready for secondary bonding. Whereas this part here that I use, just straight perforated release sheet, it's all shiny. It looks fine. There's little dimples where the epoxy came through, but I would have to abrade this, sand it down if I wanted to bond anything to it. So kind of different. They kind of work a little bit alike. There's a layer in between there, but they have different purposes. Yes?
You have to be careful about wrinkles in the separator sheet.
Yes. So the question was, what about wrinkles? Or you have to be careful about that. Depending on the surface that you want, yes. That's why I said you want to spend an additional time working that perforated release sheet out so there's no wrinkles, or as best you can. Because if it overlaps or wrinkles, you're going to actually see a small little wrinkle in that. And if depending if you want a nice perfect surface, it's not going to happen on the outside with these materials anyway. So yes, you're going to get wrinkles in there if this material is wrinkled also. Other questions here?
How many layers of carbon fiber do you need to
the question is, how many layers of carbon fiber do you need? That's really depending on the structure that you're after.
Can you use it on the whole plane, or?
Can I use carbon fiber on the whole plane? If I design the plane to be designed in carbon fiber, yes, I could. I mean, Lancer, a bunch of new models out here on the field use carbon fiber, yes. Right here?
How about the tensile, the modulus of the different carbon? We say if you go online, you can get some stuff that isn't.
Right. So there are. I've done some research on that. The question is, what about the different tensile modulus of the types of carbon fiber that are out there? As home builders, chances are we're going to buy the more economical grade that's out there. But there are a couple of ones that you'll have to design around. If you have an unlimited budget, possibly you can afford the higher grade stuff. But most of us will probably buy stuff that's a little less stronger. That's what I've seen is the cost, and also you get with the cost you get the added strength. One more.
Yeah. The other part is, what about shelf life of the
Resin
sizing? Say if you buy something this year and you don't end up
okay.
assembling it for 5 years.
What's the shelf life of some of these materials?
I'll be on the sizing on it.
Sizing.
What makes the resins, the treating of the cloth and the fibers to make the resin stick to it?
Such as the like peel ply, possibly the size. No.
No. So the fibers themselves are treated.
Okay, so what's the longevity of the fibers that has a volant onto it? Fiberglass and carbon fiber is treated to stick to epoxy resin systems. So the question is, how long does that stuff last? I would say go back to the manufacturer. They'd give you a better answer than I could. I've used stuff for at least 5 years and it seems fine. I suppose if you get something that's 20 years old, you may have some problems there. Other question here?
Yeah, you'd mentioned you could laminate carbon fiber over fiberglass. Could you do the same thing over aluminum, or would the expansion be a problem?
Okay, I'm going to throw something out here for you. I don't think you should ever mix materials for lots of reasons, because they expand and contract at different rates, and you're just asking for problems in the future. So bonding the carbon fiber to aluminum is, in my book, a really bad idea. Even using fiberglass with carbon fiber, you see people do it all the time, but realize this stuff's super stiff, it doesn't change its shape, and you're basically creating a tension when that fiberglass heats up, it wants to internally expand, and you're just asking for problems in the future. Yes, if it's just one little layer and two little layers, maybe it's going to hold together, but realistically, you're creating internal forces inside this layup if you do one of one and one of the other. Okay, question here?
Using amphibious floats, would you go carbon with the other corrode issues or fiberglass?
The question is if you're making carbon fiber floats, issues with corrosion possibly?
Use fiberglass instead.
That's a good. I don't think carbon fiber. It doesn't corrode in salt water. Carbon, even though it acts like a metal because it doesn't like radio waves don't penetrate it. But I've never heard of it actually having been corroded with salt water or something like that. My only concern with making carbon fiber floats per se is it's rather brittle. You've got a lot of impact loads when you're landing on water, and I'm just not sure. I mean, it can all be designed it can all be designed around. But my concern was, this is a rather brittle material, and having pounding on it every time you take out or land on water may maybe be too much for it if you design around it. Other materials are more flexible, like Kevlar, may be more durable than carbon fiber. Yes, right here?
How many layers of carbon fiber you figure you can wet out doing your poor man's
Yes.
step?
Question is, once again, how many layers of carbon fiber can I wet out doing this poor man's prepreg? As I mentioned earlier, I do 2 at a time, and then after that I keep stacking. So you can do 10 layers, but start off with 2, they'll wet out adequately, have a little excess resin, put another layer on top of that, another layer on top, wet that out. Once that's wetted out adequately, put the next layer on, and you can just keep building a stack. Now the concern is, as it gets thicker, you have to consider, how am I going to cut it? And if it's 10 layers thick, now you're limited on if you need to trim it right away before it goes into a mold per se, it becomes kind of unworkable. So in that case, you may want to work with only 2 to 3 layers at a time. If you're going to build something that's going into a mold that's 10 layers thick, put in the mold at 2 at a time or 1 at a time after that. So that's some of the other considerations. Yes?
You need to worry about orienting
The question is, do you need to worry about orienting the strands? Absolutely. So you need to know your layup schedule and why you're laying things a certain way. If you're building from plans or a kit or designing your own thing, you're going to design around the strength because there's going to be more strength in one direction than the other based on where the fibers are oriented. Yes? Okay, so I think I understand the question. How do you bond? So if you have maybe two pieces of tubing that are made of carbon fiber, and you want to bond those together. Well, I like, okay, so here's the example. We have two carbon fiber tubes, and we're going to make our carbon cub out of framing, maybe, who knows, something along that line, okay? First off, what's really nice about these materials is things like super glue stick to them really well for tacking things together. So first off, I'd scuff the whole area, prep it, make sure there's no fingerprints and all oils and whatnot. And you can tack it in place, tack the entire frame up with super glue, okay? After that, I put a structural filler like flock cotton and fill that, make a nice fillet around there. And then you can actually use some of this bidirectional cloth and cut strips and wrap it around there. Or you could also do some filament winding. I've seen that done. So you can do a combination of the two. If you want to, you can actually buy carbon tow, which is basically this stuff here on a roll. If I can pull it out. Maybe, no, this has got a binder on it. I probably got a little piece somewhere. Here we are. So you can buy the carbon tow and you do a winding all the way around it. And build it up with epoxy, wet it out as you go, and do some testing on how well you like it. So do a sample piece, just like you're welding tubing. After you're done, you put it in a vise and you see how strong it is. Do the same thing with that method.
You mentioned that it's not good idea to mix fiberglass and carbon. But what about Kevlar? I heard about Kevlar.
Yes. So if you do your testing, all I can say is there's some general principles that I would say. They change at different shapes. Do your testing. If you bond them together and they meet the strength that you're after, there's nothing wrong with that. But I'm just going to say there's risks involved when you do bond things together as they change their shape, as they heat and contract. So I'm not going to say don't do it. What I'm saying is there's some risks involved, so do some testing around that if you decide to do that. I got time for one more question. I think I probably got to clean up. So go ahead.
In which cases would you need metal filler for lightning protection?
All right, so the question is lightning protection. What do we do for our carbon fiber airframes and protect them against lightning? There are screens out there that's a mesh. Typically you embed that either in the mold, so it's on the outside, and it's a big pain in the butt to put this together to make sure the mesh is completely intact together. But it's something that you can do, and you can acquire from composite suppliers. They do have a mesh that's built in there in your layups, and you can actually make it so it's lightning protected from lightning. All right, guys, I gotta clean up here and finish things up. Thanks for coming by. Hope you learned a few things about carbon fiber. I'll see you maybe at a photo workshop. Thank you. And we have a few more books here if we ran out earlier if you wanted some specifications on aeropoxy.